Module 2 problems. We're starting to talk about periodic table and atoms, moles, molecular masses, that sort of thing. And so we're going to start with problem 1, where it asks what's the mass number of an atom of cobalt that has 32 neutrons. Okay, and so what you need to realize let's talk about the periodic table first. If you were to look up cobalt, you need to know its symbol is CO. If you look it up in the periodic table, you find that it's in box number 27. All right, and what that defines a few things. It's very specific. Box number 27, we'll say on the top, will have the element that has that symbol, which in this case is cobalt. It means it has 27 protons. So 27 protons defines two things. It defines which box number you go in, and it defines what your symbol is, your chemical symbol. All right, so cobalt has 27 protons. Now, this particular isotope of cobalt also has 32 neutrons. So 27 plus 32 equals 59. That is its mass. It's usually written in the upper left corner of the symbol when you write it in a problem or somewhere, okay? So it asks for the mass number. So the mass number is 59. It's not 59 point anything. It is protons plus neutrons. So protons plus neutrons equals 59. That's the mass. That is number 1. All right. Number 2. Same kind of concept. We're looking, in this case, at technetium-99. See how it's written in the problem? So it's Tc99. Okay, if you look up Tc in the periodic table, it'll look something like this. It'll be a little bit neater, but it'll look like this. And so it's box number 43. So number of protons equals 43. Number of neutrons, remember, protons plus neutrons equals mass. All right, so protons is 43. Mass is 99. So 99 minus 43 equals 56. That is the number of neutrons. Okay, so number of electrons. We're not, this is not Chem 130. We're not teaching you about ions. We're not doing too much there. So if there is nothing here that indicates a charge, typically you're going to have +1, +2, -1, -2, whatever. You have some sort of charge. If there is no charge, if it's neutral, then what that means is the number of protons equals the number of electrons in a neutral atom. Neutral, oh my gosh, I was writing atom. Okay, so that means in this case, number of electrons is 43. That's it, that's number 2. Okay, number 3. We're asking which of these below has the greatest number of neutrons. All right, and so we're going to have to figure it out for each one. These are the boxes. So these tell you how many protons each of these nuclei have. These are the masses of each of these nuclei. So neutrons equals mass minus protons equals neutrons. That's what we're looking for. So for iron, it's 52 minus 26. For cobalt, it's 57 minus 27. For nickel, it's 56 minus 28. And for manganese, it's 56. They can have the same mass, isn't that weird? They can, but it only has 25 protons, okay? So if you figure this out, this is 26 neutrons. This one's 30 neutrons. This one's 28 neutrons. This one's 31 neutrons. So it asks, which has the greatest number of neutrons? So it's this one. So manganese 25. Or manganese 56. All right, last one. Now we're going to write it a little bit differently. Iodine 131. So again, when you write these as symbols, typically you write them like this. That's a particular isotope of iodine. Iodine has 53 protons. Okay, so we want to know how many protons, neutrons, and electrons, should be an S there, are in this isotope. All right, so iodine has, by definition, it's in this box. It is this symbol, because it's an I, 53 protons. There is no charge indicated, so there are 53 electrons. Mass minus protons equals neutrons. So 131 minus 53 equals N. So the number of neutrons is 78. N equals 78. And that's it. That's for that particular isotope of iodine. We'll do problems in a little bit that explain different isotopes and what we do with that and how we actually get that number that is typically written on the bottom of the box on the periodic table. That's 1 through 4.